So for 2019 question 4, you have a cylindrical barrel with a diameter of 2 feet, and they give you a rate of change of the height. They tell you that the volume of a cylinder is V equals pi times r squared h. We're going to find several things having to do with that. By the way, if you haven't already done this problem, please pause and try it now. So before we even start the problem, I'm kind of going to read through it, and I know that I need to figure out the rate of change of the volume of the water, among a few other things. So before I actually do the problem, I'm going to figure out what dV dt is. So I know that V equals pi times r squared h. I also know that dV dt is going to be the derivative of that. So I need to differentiate that. This is a related rates problem. If you don't remember that, I recommend that you review that part of your notes. So I'm going to differentiate, take the derivative with respect to t. So we're going to use implicit differentiation when we do that. So let's start with this one. I'm going to do the product rule. I'm going to do the first thing, which is pi r squared. I'm putting the pi and the r squared together, times the derivative of the second. The derivative of h is 1, but I have to multiply by the derivative of h with respect to t. That's actually using the chain rule. So I get dh dt. Then I'm going to do the second thing, which is h, multiplied by the derivative of the first thing. So the derivative of pi r squared is going to be 2 pi r. Again, please don't forget to put the dr dt, and that's going to be times h. So there's a few things that I have right now. The other thing that I know is that dh dt is equal to negative 1/10 times the square root of h. To make things easier on myself, I'm actually going to write that as h to the 1/2. You can write it either way. I know that the diameter is 2 feet, which means my radius is 1 foot. And I know that time is measured in seconds. So let's go ahead and do this problem. So I actually forgot to mention probably one of the more important things to figure out, and that is our dr dt. The dr dt is the change in radius over time. If you look at the cylinder to the left, one thing you can figure out that's going to happen is as the water leaves the cylinder, the radius is not going to change. So the rate of change of the radius, the dr dt, is going to be 0. That's going to help us a lot. Okay, so we are trying to find the rate of change of the volume, which we already know is dV dt, when the height of the water is 4 feet. So our h is 4 feet. So there's a few things that we're going to do. I'm going to go ahead and substitute in everything I know so far. There's going to be a few other things that I need. So I know that r is always 1. I don't yet know dh dt, but that actually is very easy to find. The other thing is, I'm going to put an r again. H I know is 4 feet. Dr dt we just said was 0. So the dh dt I can find by using that formula that I have, negative 1/10 times the square root of h, which in this case is 4. So it ends up being negative 2/10 or negative 1/5. So I get pi times negative 1/5. That's going to be plus 0. So it ends up giving me negative pi over 5. My units of measure, keep in mind that I'm working with volume, so there's going to be something cubed. Volume is often meters cubed, inches cubed. In this case, we're working with feet, so it's going to be cubic feet. However, this is the rate of change, so it's going to be cubic feet over time, which is going to be seconds. By the way, this question is worth 2 points. You get full credit if you have the answer with the correct units. That gives you 1 point. You also get a point for getting this step right here. And there's actually an alternative way to do this problem that you might find a little bit easier. I like the method that I chose personally, but I think that some of you might like this better. You have to notice something though. So we know that the volume of a cylinder is V equals pi r squared h. Because we know that the radius is always 1, we are permitted to just plug in 1 for r, which gives us V equals pi h. And then you can take the derivative and you get dv dt equals pi dh dt. That actually will skip a lot of the middle step that you have, and that'll get you to this point right here. So you're allowed to use that either way. So this would be method 2 for doing this problem. It's shorter, but you do have to notice that r is always equal to 1. So part B is a little bit tricky. They tell you when the height is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. So they don't want to know if the height is increasing or decreasing. They want to know if the rate of change of the height is increasing or decreasing. So I'm going to write a little explanation on the side just so you know the difference between those two. So first of all, I think a lot of people get this problem wrong because they think it's asking, is the height increasing or decreasing? If they ask that, what you would need to do is you would need to find if dH dt was positive or negative. Unfortunately, they're not asking that, so that's not what you're doing. They are asking if the rate of change of the height is increasing or decreasing. If you just find out if dH dt is positive or negative, that tells you if the height is increasing or decreasing, but the rate of change of the height increasing or decreasing, we have to go one step further. We actually need to find if the second derivative, d squared h dt squared, is positive or negative. So be really careful about this. This was one of the most missed questions because people actually made it too easy. So sometimes if you make things too easy, oftentimes if you just have to plug in numbers only without actually using any calculus, that's often a sign that you oversimplified things. So if you just did this problem by plugging in 3 for that equation that I have written there, that was not the right thing to do. You have to do one extra thing. So the one extra thing we're going to do is we're going to take the derivative of this dH dt. So to find the derivative of that, we are going to use implicit differentiation. We get 1/2 times h to the negative 1/2 dH dt. Don't forget that dH dt right there. Now we can actually plug in some numbers. So I end up getting negative 1/20 times the square root of h times dH dt. So then when h equals 3 feet, we can put in h equals 3. We also need to substitute in dH dt. That is going to be negative 1/10 times the square root of 3. So my total overall answer to the second derivative is going to be negative 1/20 times the square root of 3 times negative 1/10 times the square root of 3. You'll notice that the radicals cancel out. We end up getting 100 or 1/200. That, by the way, that's not the answer, but you're almost there. So this second derivative is going to tell us that the rate of change of the height of water is increasing. So you do need to explain your reasoning, meaning you should probably write a sentence of some sort and have supporting work, which we have the supporting work. The sentence I wrote is because the second derivative of h with respect to t is greater than 0, the rate of change of the height is increasing. So for this problem, it's actually worth 3 points. Unfortunately, if you just plugged in 3 for h, you would have gotten 0 points. To get the first point, you have to do at least half of the second derivative, meaning this part. You actually can get that point if you forgot to use implicit differentiation. To get the second point, you also have to have that dh dt. And then to get the third point, you need to have the explanation. You have to say the rate of change of the height is increasing, and you have to mention that the second derivative is positive. So that's your third point. For part C, they asked you to use separation of variables. Another way they sometimes ask that is solve the differential equation. They also tell us that h of 0 is going to be equal to 5. So in order to solve this one out, we are going to put all of the h terms on one side, put all of the t terms on the other, and then we're going to take the integral. So I have dh. I'm going to move over that radical h. I'll keep the negative 1/10 where it is. It doesn't really matter where that ends up. As long as you have it, you can have negative 10 on the other side, but as long as you can keep that in the end. So now I am going to take the integral of both sides. So first thing I'm going to do is rewrite the integral on the left-hand side as h to the negative 1/2 dh. And the one on the right-hand side, I'm just going to pull out the negative 1/10. So I have a dt. So the integral of h to the negative 1/2 dh, the antiderivative of h to the negative 1/2 is 2h to the 1/2. On the right-hand side, I end up getting negative 1/10 times t. I also have a plus c in there. So now that, don't forget that plus c, by the way, you can only get, I think, maybe 1 point or something for the whole problem if you don't put the plus c in there. You do need to use that initial condition, the h of 0 equals 5, in order to actually solve this problem. So I end up getting 2 times the square root of 5, I'm going to rewrite h as a radical, is equal to negative 1/10 times 0. That gives me that c is equal to 2 radical 5. So the last thing the question asked me to do is find an expression for h in terms of t. So what I'm going to do is I'm going to take the expression that I got right here. I have two things I need to do. I need to substitute in the c. The other thing is, since I am finding something for h in terms of t, I have to solve for h. So let's go ahead and work this out. I get negative 1/10 t plus 2 radical 5. I'm going to solve by dividing everything by 2. I get negative 1/20 times t plus radical 5. Final answer, I need to square both sides. So I end up getting this right here. So this problem is actually worth 4 points. You get the first point by doing separation of variables. You get the second point by correctly taking the antiderivative of both sides. The next point you get by finding your c. And then the final point you get by rewriting h as this expression right here. If you did not simplify that final expression, by the way, like if you just wrote this over 2, that's fine as long as you did get h by itself. But if you have something like the expression I just have up there in yellow, that is an acceptable answer. You don't need to simplify in the end, but you do need to solve for h. That's the only thing you have to do on this problem.